Alright guys, welcome to Chapter 2, Section 4. Today we're going to find maximums and minimums, and we're mostly going to use our calculator to do this, so that's a good thing. This is perfect for the ACT test, finding maximums and minimums. And the objective is to write a polynomial function for a given situation and to find the maximum or minimum value of a function. Okay, so once again, we're finding maximums and minimums, and we're going to pretty much do this 99% of the time using our calculator. Okay, so let's get started. All right, so different types of graphs have either maximums or minimums. So if we are looking at a parabola, let's say we have a parabola like this, this particular point down here is called a minimum. Okay, called a minimum because it's the lowest point on your graph. Now, vice versa, if our parabola opens downward, this point up top is called the maximum because it's the very topmost point. Okay. Now, what happens if we're doing an x cubed graph and it looks like this? Well, this one has a maximum and a minimum. Okay, it has a maximum and a minimum because it has one high valley and one low valley. Okay. And what happens if we are doing an x to the fourth that opens up? Okay, so depending on which one is the lower of the two valleys, one of these is going to be your minimum. Okay, so when I say maximum or minimum, that's what we mean by that. Okay, so we're going to do a couple of examples to hopefully make some sense out of this idea of maximums and minimums. So, example 1, find the maximum or minimum of the following polynomial. What we're going to do is we're going to graph using our calculator. Okay, so I'm going to click over to my calculator. Our equation is y equals 3x squared plus 2x minus 6. Okay, so if you notice, oops, not right there. Alright, so there's my calculator. So if you notice, I have a bunch of equations typed in, but I'm only looking at the one on the top, 3x squared plus 2x minus 6. And that was the only one that's on, so that's the only one I'm going to graph. Okay, so when I hit graph, and we notice that it's a parabola, and, oops, sorry, I got too many turned on. I need to go down here and turn a couple of these off. Okay, so this very last one is turned on, so I'm going to turn that one off by hitting enter on the equal sign. Alright, so the only one that should graph now is the very top one. Okay, the one with the equal sign that is highlighted. Okay, so I'm going to hit graph again. There it is, there's my parabola. And now what is this point down at the very bottom called? That should be called a minimum, so that's what we're going to find. So this is what you do. First step is to hit second, trace, and now look at 3 and 4. One's a minimum, one's a maximum. Those are the only two that we're going to be using today. So we're going to do 3, the one that says minimum. And this is the tricky part. It says left bound. So you want to move to the left, and you just want to make sure your cursor is to the left of that very bottom point. Okay? So as long as that cursor is to the left of this bottom point, you're good. So you're going to, once it's to the left, you're going to hit enter, and then it's going to tell you that it wants right bound. So that means you move your calculator cursor to the right of this very bottom point. Once it's there, you hit enter. And then once it guesses, you hit enter again. And it should tell you what your minimum value is. And this is an ordered pair, so it's negative 0.33. So, oops, let me get on the pen. Negative 0.33, comma, and what was our y value? Negative 6.33. Negative 6.33. Okay, so that is ours. So if you want to write minimum next to it, that'd probably be a good idea too. Okay, so the minimum equals negative 0.33, comma, negative 6.33. So that's how you use your calculator to find minimum or maximum. Okay, so let's look at example 2. Okay, a little bit harder here. We have a story problem, and it says a rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimensions of the pen that give the greatest area. Okay, so let's walk our way through this problem. Okay, so it says one side of your pen is a barn wall. Okay, so here's your barn. Oops. Okay, and now we're going to basically be building a three-sided pen. Okay, now 99.10% of the time, your width of your rectangle is always going to be x. So we have two widths, so there's two x's there. Now let's think about this. How many meters of fencing do they give us to use? 60 meters of fencing. So we have 60 meters and we've removed two x's from that 60 meters. So the remaining side is 60 minus 2x. Okay. Now the rest of the problem is actually fairly easy. What does it want to know? It wants to know what the greatest area is. What is the greatest area? So we're going to come up with an area formula. Okay. Hopefully you remember that the area of a rectangle is length times width. Okay, so let's see what we have here. So area equals length times width. Our length is 60 minus 2x, and our width is x. Okay, so there is our formula. We're now going to use the calculator to find the greatest area. Okay, so now I'm going to go back to y equals. I'm going to turn off the first one, and if you notice, I have 60 minus 2x times x. Now they're just reversed, but the order does not matter. So it's 60 minus 2x times x. Okay, so we're going to graph it. And I cannot see anything. But we're trying to find the greatest area. So we're trying to find a maximum. So I'm going to have to go up. So if you hit window, we're going to need to go up some more y. So our y max is currently at 10. Let's change it to 50 and let's see if that does anything. Okay. Now notice I can see more of my graph, but I haven't gone high enough. So we can go to window. Let's change this to 150. And let's see if that works. Oh, still more. Still need to go up more. So instead of 150, let's try 300. Still need to go more. Okay, so 300. Let's try 500. And I'm going to move I'm also going to go some to the right because it looked like I needed to. So I'm just going to change my x maximum to 50. Okay, what do you notice? There it is. There's my maximum of my graph. So that is now what I need to find. So go back to example 1, second trace. Now we're going to find number 4, which is a maximum. Okay. Okay, so it says first, oops, I think I clicked the wrong one. Second trace, number 4. Okay, so it says left bound, so I need to move that cursor so it's to the left of that maximum. Okay, enter on that one. Now I'm going to move my cursor to the right bound, hit enter, and then when it says guess, you hit enter again. Okay, so what is it telling you? It says x equals 15. So x equals 15. Let me get my pen here. X equals 15. And y equaled 450, I believe. Okay, let me double check. X equals 15, y equals 450. So what does that mean? Okay, so our maximum area is always our y value. You're always using the y value as your max or your min. So it's 450, and what we're in, meters squared. That is our maximum area. Now, what else does it want? It says it wants the dimensions. The dimensions are your x values. So our width is x. What does x equal? 15 meters. And we get that from our x value. And what is our length? 60 minus 2 times 15. 60 minus 30 equals 30 meters. So our length, our width is 15, and our length is 30. And the maximum area is always your y value, so 450 meters squared. Okay, this will be a little confusing at first, but once you do a couple, it will make some sense. Okay, let's look at example 3. Okay, basically the same premise as the last one. It says squares with sides of length x are cut from the corners of a rectangular piece of sheet metal. So let's draw that picture first. Let's draw that picture. We have a rectangle. Not a very nice looking rectangle, but it's a rectangle. It says squares with side length x are cut from the corners of the rectangle. Okay, so basically we have a rectangle here, square here, a square here, a square here, square here, and it says the widths of those are x. Okay, so each of those are an x value. Okay, what else does it tell us? It says, and it had the sheet of paid metal has dimensions of 6 inches by 10 inches. Okay, so what does that mean? That means that our width from here to here is going to be 6 inches, and from here to here is 10 inches. Okay, and basically what it wants, it says what it's asking us for, what is the maximum volume of such a box? Okay, so basically what we're doing is we're folding up each of these corners here. So if I draw a dotted line, oops, let me get rid of that. That is a mistake. Let me redraw this really quick. This is x and x. So if we draw a dotted line here, 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 and a dotted line all the way across. So if we fold all these dotted lines, it's like an open top of a present box. Okay, that's what we have. So first thing we need to figure out is volume. What is volume? It's length times width times height. Okay? So the volume equals the length is 10, and then we have to remove each of these x's when we fold it up. So 10 minus 2x. The width is 6, but we have to remove these two x's, so 6 minus 2x. And what's our height? The height is just the length of one of these little squares when it's folded up, so it's just x. Okay, so there's our formula that we're going to type on the calculator. Okay, so I'm going to go with my calculator. Let's see here, I don't know why it keeps doing that. So there it is. I'm going to turn off my second equation, and I'm going to turn on the third one down. X times 10 minus 2x times 6 minus 2x is the correct equation. Now, when I hit graph, it's not the right window, so I need to hit zoom 6. All right, so we're back to our main screen here. Now we're finding the maximum value again, so I need to go up. So instead of 10, let's try 100. Let's try 100, see if that works. Yep, there it is. There is our maximum value that we want to find. So second trace, maximum, and it says left bound. So I need to just make sure that there's cursors to the left of my maximum, that very top point. So enter on the left, move it now to the right, enter there, and then when it says guess, you enter again, and it should tell you your x values. Okay, so your x value is 1.21, so x equals 1.21, and y equaled 32.8. 32.8. So y equals 32.8. Okay, so what does it want? It says what is the maximum volume? Remember, the volume or the area is always your y value. So your volume equals 32.8 meters, and it's a volume. There's 3 of them here, so it's meters cubed. Okay, so that is dealing with maximums and minimums. I have an example 4 here. We'll do this one in class tomorrow just to make sure that everyone's on the same page, and we'll do a few more examples to make sure everyone knows what they're doing. Thanks for watching. I will see you tomorrow. Have a great night.